I want to finish today with some observations. So if you look at the mutual information between x and u minus the mutual information between y and u, of course we can write it also in this way. So we just write this, the formula for this in terms of entropy, and this in terms of entropy, and then we remains with this expression. This we can reform to that expression here. We just add here the condition y. But if you look at this expression, that's just the mutual information between x and u under the condition y. And if you look from the decoder perspective, this is very intuitive because we can regard u as representing the index w because we use this for our coding book. That means the information I get, we have here the mutual information between the output of the source. Here it's somehow the coding book under the condition that I know y. And that somehow is also intuitively that this might be a good rate, that this might be the rate. But this is only from the decoder perspective, because the encoder, for the encoder, we do not assume that he knows y. So for this reason, let's do the next observation. So we can write this mutual information also at this mutual information here, because we can of u and x hat here, because x hat is is a function of u. But this is greater or equal than the mutual information between x and x hat and y. We just leave out this u and then the mutual information gets smaller. And this is of course equal if the mutual information between x and u is equal 0. But this corresponds to the case where the encoder also sees y. And this can be seen also as another problem. So we can consider the model when both the encoder and the decoder have access to the site information. And of course, in this case, instead of writing the mutual information of x and u minus the mutual information of y and u, we can insert this expression here, the mutual information between x and x hat under the condition y. So this is less than RVZ of d for the most common sources and distortion functions, because we have this is greater or equal than this. So this is the same like this expression we have in our function RWZ, but this estimation is only the same if we assume that the encoder also see y. So this is somehow the achievability part if we assume that the encoder also see y. We will see that this is also true in totally. That means the converse also holds for this case.